The expression in part D is 1 minus 2 times the sine squared of 22.5 degrees. Okay, so we're doing the same kind of thing. Okay, this is some expression that's been given to us. We're trying to, quote, simplify it or turn it into an equivalent expression. Okay, this particular expression does not have a variable, so we should be able to get an exact answer. Okay, again, 22.5 degrees, not on the unit circle. You have to be able to provide an exact answer without using your calculator. Okay, you may not be allowed to. Okay, so let's do this. We're going to match this expression up with one of the double angle formulas. Okay, so back to page 1. Okay, we are looking for, again, if we read what we're trying to match up here, 1 minus 2 times sine squared. So that's what we need to be looking for. Okay, pay attention to this column. Where do we see 1 minus 2 times sine squared? Well, I see it in equation number 3. Okay, so this is the one that I'm going to use for this expression. Okay, it's one of the 3 double angle formulas for cosine. Okay, so let's go write it down. I know that 1 minus 2 times the sine squared of A, that is the same thing as the cosine of 2A. Okay, I am going to match it up with what I have been given, which is 1 minus 2 times the sine squared of 22.5 degrees. I'm just going to go ahead and write 22.5. Okay, 22.5 degrees. Okay, and luckily this is another exact match. Okay, when I try to match up the two left sides here, I see the 1 minus 2 times sine squared, and the only difference I see are the arguments. Okay, so we know that if we're converting from the double angle identity to our expression, we know that the A value is 22.5. All right, so I'm going to write that down. So here our A value is going to be 22.5. So we've got an exact match on, the left-hand side. So to write down what our expression is equal to, we can apply the right side of the double angle identity. Okay, what we have been given is going to be equal to the cosine of 2 times A. So that's going to be the cosine of 2 times 22.5 degrees. Okay, so if you multiply 22.5 by 2, you're going to get 45. So this is equal to the cosine of 45 degrees. And the cosine of 45 degrees is the square root of 2 over 2. Okay, that's it. We're done. Okay. All right, so that's how you could have figured out the exact value of this expression without a calculator. Couple more on page 6. So looking at part E, now we've got the expression cosine squared of pi over 8 minus 1/2. Realize here before we start this problem that you are taking the cosine squared of pi over 8. So once you have that quantity, then you just subtract 1/2 from it. Okay, this is not saying that you're taking the cosine of pi over 8 minus 1/2, and then once you have that value and you square it. That's not what this is saying. Okay, so again, how you interpret this, you're taking the cosine of pi over 8, you're squaring that result, and then you're subtracting 1/2 from that. Okay, we need an exact value for this. Pi over 8 is not on the unit circle. Okay, you may not be able to use your calculator. How would you do this? Apply a double angle formula. Okay, we need to match it up. We need to find something that has cosine squared minus 1/2. Okay, let's go see what we have. Okay, but this is what we've been given. So if we go take a look at the double angle formulas and look at the right column, what do I see? Well, I see right here in number 4, I see a cosine squared minus 1. Okay, so it's the one that most resembles our expression. So we're going to go with it. Okay, so we're turning to our work. I'm going to write down the double angle formula. So we have that 2 times the cosine squared of A, minus 1 is equal to the cosine of 2a. Okay, so this is the double angle formula that we're using here. Okay, now we have to match it up to what we've been given. So I'm going to write it down. Cosine squared of pi over 8 minus 1 is equal to, okay, we'll get to that. Okay, all right, let's compare the left sides. Okay, so I definitely see the cosine, oops, I didn't write this down correctly. Hold on, I forgot the 1/2. Hang on. Okay, so we were given cosine squared of pi over 8 minus 1/2. Okay, now let's try to match them up. Okay, so we see a match with the cosine squared. Okay, and I see the minus matching up, and that's about it. Okay, the argument is easy to decipher here. What you're taking the cosine squared of is pi over 8. So we can go ahead and say that the a value has to be pi over 8. Okay, so what's a little confusing is the numbers. Okay, so the original identity, the double angle formula, it has 2 times the cosine squared of a minus 1. And in our expression, we don't have a 2 multiplied out front of the cosine squared, and we're subtracting 1/2, not 1. Okay, so what this tells us is we're going to have to do some adjusting of the coefficients here, and it's actually pretty straightforward. We had to do this in one of the earlier problems. Okay, I want a 1 in front of the cosine squared. Okay, so to get rid of the 2, okay, to make it a 1 in front of the cosine squared in the double angle identity itself, I'm going to divide by 2. Let me put this in a different color. I'm going to divide by 2. I have to, if I do it to the first term, I have to do it to the second term. So I'm going to divide the entire left side by 2. Okay, this identity is an equation. So if you do something to one side, you have to do it to the other. So this is what it's going to look like. And then what happens in my identity? Okay, it becomes what? Well, everything in the top has to be divided by 2. Okay, so we're going to get 2 times the cosine squared of a divided by 2. We'll have the minus sign in the middle, and then we'll have to take the 1 and divide it by 2. Okay, so then you see the 2 cancel here and the 2 cancel here, and we're left with an exact match of what we have. Okay, I see the cosine squared with a 1 in front. Okay, my argument is pi over 8, and then I'm subtracting 1/2. Okay, these guys actually match up now. Okay, so we accomplished that by taking our double angle formula and we divided both sides by 2. That's how we adjust the coefficients here. Okay, so now we can write down what our given expression is equal to. Okay, the cosine squared of pi over 8 minus 1/2, follow the right hand side of the equation over here. Okay, this is going to be the cosine of 2 times a is pi over 2, divided by 2. Okay, so this is going to be the same thing as if you're dividing by 2, you can multiply by 1/2. So this is going to be 1/2 times the cosine of pi over 4. Okay, so we keep going. This is going to be 1/2 times the cosine of pi over 4. The cosine of pi over 4 is the square root of 2 over 2. Okay, so we multiply across the top, across the bottom. Here is our answer. Okay. All right. One more. Okay. So in part F, our expression is 1/8 times the sine of 29.5 degrees times the cosine of 29.5 degrees. Okay. Again, I need to match this up with a formula. Okay. So going back to page 1, I'm looking for sine times cosine, okay, maybe with a number in front, okay, and I see equation number 1, okay. I see sine times cosine. There's a number out front. It's not the number that we have, but this is the closest match of all the formulas, okay, so that's the one I'm going to use. So I know that 2 times the sine of a times the cosine of a is equal to the sine of 2a. Okay, this is our double angle formula for sine. Okay, we're going to try to match it up with what we have. We have 1/8 times the sine of 29.5 degrees times the cosine of 29.5 degrees. Okay, and we want to get an exact value for this guy. All right, start matchy-matchy. Okay, I see a sine, I see a cosine. I can match the arguments up. Okay, a is going to equal 29.5 here. So again, the only problem is the number out front. So let's talk about how to do this. Okay, in the double angle formula itself, on the left side, the sine and the cosine are multiplied by 2. Okay, in our expression, we're multiplying by 1/8. Okay, we have to get a match. So in the double angle identity, we want to adjust things so that we are multiplying by 1/8, not 2. Okay, so I am going to come along and I'm going to put this in another color. To change this 2 to a 1/8, I'm going to have to multiply by 1/16. Okay, because 1/16 times 2 is 2 over 16, which is 1/8. Okay, if I do this to the left side of the identity, I have to do it to the right side of the identity. Okay, so the right side of the identity is going to become 1/16 times the sine of 2a. Okay, and the left side is going to become 1/8 times the sine of a times the cosine of a. Okay, and now we have the coefficients matching. I see the 1/8 times, the 1/8 and the 1/8 matching. Okay, all right, so now that we've gotten an exact match, we know what to do. Okay, we're going to follow the right hand side right here. We're going to follow what I just circled. Okay, so 1/8 times the sine of 29.5 degrees times the cosine of 29.5 degrees is going to be equal to 1/16 times the sine of 2 times a. A is 29.5 degrees. Okay, so this is going to be 1/16 times the sine of, let's see, what is that going to give us? 29.5 times 2 is going to give us 59. So we end up with this strange answer, 1/16 times the sine of 59 degrees. Okay, 59 degrees is not on the unit circle. Okay, so you might be thinking, okay, I did something wrong. This is actually the answer. Okay, because it would take like a calculator to compute the sine of 59 degrees, this is as far as we can go. This is actually the answer. Okay, 1/8 times the sine of 29.5 degrees times the cosine of 29.5 degrees is the same thing as 1/16 times the sine of 59 degrees. Okay, I guess this is one of the situations where the answer is considered simpler. But remember, it's just an equivalent expression.